Hi, and welcome to another edition of As the Page Turns. That's right, we're moving on to section 4.3, Multiplying Polynomials. Again, I'm assuming, I hope it's a safe assumption, but I'm assuming that you're reading the book. You're not going to get everything out of just watching these videos, though I hope that they're very helpful. But you probably know you have your own work to do. In section 4.3, I'm simply going to be going over some of the examples that are present and explaining them as we go. We'll start on page 4.3-1 with example 1b, which asks us to multiply. We're going to multiply negative, and I'll put this in parentheses because it represents one term. It's negative 5x squared y times 4x y cubed. And if we think about this, everything is being multiplied here. We have the negative 5 being multiplied to the x squared, which is being multiplied to the y, which is being multiplied then to the 4, and times the x, and times the y cubed. You don't need to write all these out. This is, though, what's actually happening. One thing I am going to do is try to get all of the different pieces together. I'll get all the constants together. And the reason we're able to switch some of these pieces, these factors around, is because of the associative property and the commutative property. So I'm going to have the 5 and the 4. I'll write them together. They're the numbers. I'll write the x squared times the x together and the y times the y cubed. So it'll look like this. Negative 5 times the 4 times x squared times x times y cubed. No addition anywhere, all multiplication. And some of this is very simple. Negative 5 times 4 is a negative 20. X squared times x. I want to remind you that we don't see the variable, or excuse me, we don't see the exponent, but there's an exponent of 1 right above the x. And so if we're going about the addition of exponents, that product rule that we saw in the beginning of chapter 4, that will make it x to the 2 plus 1, or x to the third power. Similarly, y has an exponent of 1, and combining those two together, it's y to the fourth. Y to the fourth. And, you know, this could have been done in just one step. If you think about, we're not doing any kind of distribution, we're just, everything, like I said, is multiplied. So it's negative 5 times 4, negative 20. Whoops. Negative 20. And then x squared times x is x cubed. And then y times y cubed is y to the fourth. So it could be done in just one step. But here's, you know, all the individual steps all the way throughout. So the explanation is there. All right? Anyways, that's section 4.3, page 1, example 1b. Let's erase all of that and go on to the next page, page 4.3-2, example 2b. And this says that we have a quantity, a single term, negative 5 x squared y, quantity squared. What happens when we're squaring a monomial, when we multiply a monomial times itself? And, well, multiplying it by itself really is the way to go about this. That's negative 5 x squared y times, I'm going to put this negative 5 in parentheses so that it doesn't look like we're subtracting anything, because we're not. It's all multiplication, and x squared y. And just as we saw before, we're going to multiply, you know, the numbers together. Negative 5 times negative 5 is positive 25, and we'll multiply the x's together, x squared times x squared. And we're going to add those exponents together. It's x to the 2 plus 2, which is x to the 4. And that's what we get here. 25 x to the fourth. And then just y times y is y squared. And there you have it. Now, you might also have remembered, by the way, I'll rewrite the problem here. Negative 5 x squared y quantity squared. How we, when we have powers to powers, when we have everything being multiplied here, how we can distribute that power as a power. If everything's being multiplied, we can distribute it as a power, and that means we would get negative 5 being squared, and x squared being squared, and y being squared. And negative 5 being squared is that positive 25 that we saw in the other answer. X squared squared, you might recall that we multiply the exponents. I know that some of these exponent rules are a little bit challenging, but this becomes x to the 4th power. And then y times y is y squared. Same answer, just an alternative method for squaring a monomial. All right? So let's go on to our next example. Example 3 on page 3. So page 4.3-3, example 3. We'll do example 3b, which says this: negative 5x squared times the quantity x squared plus 4x plus 1. Did I do that right? Oops, that should be minus 1, excuse me. Okay, there, now it's minus 1. And what we're going to do here is distribute. When we distribute, we're going to multiply negative 5x squared times each of these terms inside. And if you think about it, it's like multiplying a monomial, negative 5x squared, times this single term, that monomial, x squared, and then coming back and multiplying the negative 5x squared again times the positive 4x term, and then coming back to the negative 5x squared again and multiplying it by the negative 1. So that's how it's going to be when we distribute. Now, I will show every step here. You might eventually, when you get better at this, and maybe even right away, I don't know, you might be able to just do it all in one step. But I'm going to show it out completely. This is going to be a negative 5x squared times x squared plus. Then negative 5x squared, let me put that in parentheses. I'll do it each time like that. Times the 4x that's there, minus negative 5x squared times the 1. Now the most unusual piece in all this actually is that minus sign right there. I wrote it as a minus, and then I said it's negative 5x squared times 1. Well, if I didn't write all these out, I might instead have said this: negative 5x squared times negative 1. And just done it all in one step. And we'll conclude this problem by actually doing it from the beginning all in one step, though. But as it is, here's what we get. Whoops. Negative 5, x squared times x squared is x to the 4th power. We could think of just adding 2 and 2 to make 4 in that case. Now, I could write plus. In fact, I will on this one case, and then when we go back we'll see an extra step is needed here. Negative 5x squared times a positive 4x. So negative 5 times positive 4 is negative 20, and then x squared times x, x cubed. So that's a negative 20 x cubed. Because I don't like to see a plus sign and a minus sign right next to each other, I'll put that in parentheses. And minus. And now simply, negative 5x squared times 1 is negative 5x squared. Let's see, negative 5x to the 4th is fine as it is. Now, plus a negative, we usually write that simply as minus. And this is the simpler way to write it, is say minus 20x cubed. So I'll write it that way, minus 20x cubed. And minus a negative 5x squared. Minus a negative. That's a double negative. Minus a negative, if we change that to add the opposite, they become plus a positive 5x squared, or simply plus 5x squared. And I believe that we're finished. We have it simplified. But let me show you this problem again from the beginning. I'm going to multiply negative 5x squared through to the trinomial x squared plus 4x minus 1. And my speaking and thinking are going to be a little bit different. Instead of writing out, that negative 5x squared multiplied by each and every one of them, instead I'm going to think of negative 5x squared times positive 1x squared, and just think of it as monomial times monomial. That would give us a negative 5x to the fourth. Then, think, before we write anything down, come back out here, negative 5x squared times a positive 4x. We should treat that plus sign as a positive 4x. So negative 5 times positive 4, negative 20. X squared times x is x cubed. The way I'm going to write negative 20x cubed, though, is a minus 20x cubed. That means the same thing. Negative 20x cubed and minus 20x cubed. Lastly, negative 5x squared times negative 1. A negative times a negative is positive. So that'll end up being plus just 5x squared. And is that the same answer we got there? Negative 5x to the fourth minus 20x cubed plus 5x squared. Yes, it is. And we're done. And the problem is already written also in descending order. Descending order, x to the fourth, then the x cubed, and then the x squared. Okay? That's example 3b. Now, after example 3, after page 3, there's this thing called page 4. Yeah, I know. And you know what? There's like page 4s after all of the page 3s. It's kind of amazing. But in this particular one, there's an explanation that I'm not going to go over right now. And I'd really like you to read it. Especially because I think it's kind of clever, But it kind of helps us set up the next example of multiplying, a binomial, 2 terms, by a trinomial, 3 terms. And this explanation on page 4 of section 4.3, clever as it is, I think it's going to be helpful, too, to your understanding of how it is that we can multiply these together. So let me erase all this. And we're now going to be skipping on to page 5. So page 4.3-5. And I'm looking at example 4, but I'm going to apply that stuff from page 4 that I would like you to read. If you haven't read it already, I certainly recommend that. I was going to say I require it. I do. So get used to it. Okay. We have 2x plus 3 times, it's not a very good 3, is it? So we'll say 2x plus 3 times 6x squared plus 4x plus 5. Oh, one thing that's nice is that it's all addition. But here's the key to this. This distribution, this product, this multiplication, requires 2 different distributions. First, the 2x needs to distribute to each and every term. We go back, 2x times 6x squared, then 2x times 4x, then 2x times 5. Then we come through and do the 3 to each and every term. 3 times 6x squared, and 3 times 4x, and 3 times 5. And I'm going to write those out. First of all, I'll do the arrows to point to each of these distributions. And I'll do them all in red first, and then I'll come back and do the 3, and I'll do those in blue. We've got those 3 distributions. So we can get 3 red products, and let's see what they are. It's 2x times 6x squared. That'll be a 12x cubed. And 2x times the 4x is a positive 8x squared. X times x being x squared. And lastly, the 2x times the positive 5 is a positive 10x. Then I'm going to do 3 times each of these, and it's a positive 3, which is nice. Looking at here, and seeing that some of these exercises have negatives, so you need to be especially careful. And we'll go over example 5 also that has some negatives, but these are all positives and makes it easier for the first time out anyway with this rather complex problem. Anyway, to continue, now 3 times 6x squared is plus 18x squared, and 3 times 4x is plus 12x, and 3 times 5 is plus 15. And so we actually have 3 products in red from multiplying 2x on through, and then 3 more products in blue from distributing the 3. A total of 6 products here, 6 terms. But some of them are like terms. For example, I see here the 8x squared and an 18x squared. I see here a 10x and a 12x. So those terms are going to be able to be combined. I notice that the 12x cubed is the only x cubed term there is, and that will start things off as the lead term and putting in descending order, and it's all by itself. But recognizing, again, the 8x squared and the 18x squared, those two together, 26x squared. So that's a positive 26x squared. And the 10x and the 12x, both of them positive, like terms, 22x. And then this 15 is all by itself. It's the only constant term we have. So originally we started, when we multiplied, we got 6 terms. We were able to simplify it down to just 4 terms. Let me show you an alternative technique here, and that is, I'll rewrite the problem. Again, it's going to be the 2x plus 3 times 6x squared plus 4x plus 5. And I'm going to do the red and the blue just like I did before. I see the 2x times 6x squared is 12x cubed. 2x times 4x is a positive 8x squared. 2x times 5 is a positive 10x. And now for those blue products. 3 times 6x squared is 18x squared. Notice where I'm going to put it. I'm going to make it a positive 18x squared. I put it right below the other x squared. So I'm aligning these, and when I add this time, I'm going to add down below, and I've already got like terms, one above the other. It'll be easier to combine instead of having to search them out. This is just, an alternative way of doing this. The next blue product is 3 times 4x is plus 12x. And lastly, 3 times 5 is plus 15. And notice how we only see like terms in the x squareds and in the x's. The x cubed had no like term partner, if you want to think of it that way. Same thing up here. Also, the constant 15 has no partner or like term with it to add together, just like 15 over here. So we're going to get the same answer, of course, because it's the same problem, but notice adding this way, 12x cubed plus 18 and 8 is 26x squared plus, and that's 22x plus 15. 2 different ways to do the same problem, obviously very similar, just a different way to organize those individual products and kind of align them up with their pairs of like terms. So anyways, that's example 4, and we'll move on to just a couple more examples, it looks like. Example 5 on page 6, so this is page 4.3-6, example 5, and I will do 5B and 5C. Now they're very similar to each other. I'm going to do just 5B, which says 2x minus 3 times 6x squared minus 5x. This time it's 2 terms times 2 terms. Binomial times binomial, but the process is the same. We'll distribute first the 2x through to each of these, and then we'll distribute not 3, but negative 3. That's right. Negative 3 to each of those. I guess those were supposed to be blue, so for the sake of consistency, I'll make those blue. Distribute the negative 3. In fact, if you don't mind, I'm going to circle that negative 3 because I want that negative to be with the 3, and I want it to be pronounced that way. Very clear that way is what I mean. So, the red, 2x times 6x squared, 12x cubed. 2x times negative 5x this time is a negative 10x squared. The 2 times the negative 5 is negative 10. In the blue, we have negative 3 times 6x squared is a negative 18x squared. I think I did that correctly. Negative 3 times 6 is negative 18, and it's x squared. Yeah, that's right. And negative 3 times negative 5 is a positive 15x. So when we add these together here, it looks like we have 12x cubed, negative 28x squared, and positive 15x. So it's just a matter of being careful because there will be a number of terms and it's easy to make a single error which will throw the whole thing off, but it's more a matter of simply being careful. Oh yes, and watch out for the signs. Watch out for a negative sign here and make sure that negative goes with the 3 when you distribute each time. And treat that as a negative 5x so that when we multiply 2x times this term here, that's 2 times negative 5, which gives us a negative 10. And here, negative 3 times negative 5, which gives us a positive 15. And it's positive 15x. Okay? Now, one last example. Example 6 on page 8. Let me erase all of this. So we're looking at example 6 on page 8. That's 4.3-8. I'm going to do both of these. First of all, example A, which is x plus 5 times x minus 5. And again, first distributing x through to each of these, and then coming back and distributing positive 5 to each of these. So let's see. First of all, the x's. X times x is x squared. X times negative 5 is a negative 5x. I'm going to continue writing it this way instead of writing one above the other, just so you see both ways. Now the 5. 5 times x is a positive 5x. And 5 times negative 5 is negative 25. And the only like terms I see are right here in the middle. But what's interesting about these is that they are exact opposites. A negative 5x and a positive 5x, they add up to 0x, which really is just 0. And when we write out the answer here, we don't need to show that term at all. It's just the x squared and minus 25, and negative 25. X squared minus 25. That 0x does not even need to show up. There is no term there. It's plus 0 if we wanted to add it at all. But it's not necessary. X squared minus 25. Here's part B of that example. 2x minus 3 times 2x plus 3. 2x minus 3 times 2x plus 3. And we'll distribute again, first of all, the 2x, and then we'll distribute the negative 3. Careful, that's a negative, so make sure it's the whole negative 3 that you're going to distribute there. And let's see what we get here. 2x times 2x is a 4x squared. 2x times 3 is a positive 6x. And let's see, negative 3 times 2x is a negative 6x. Oh, that's nice. And negative 3 times positive 3 is a negative 9, or minus 9. And when I said, oh, that's nice, I saw the positive 6x and negative 6x again. They're going to again be 0. That's kind of nice. Well, it just gets us down to two terms here. 4x squared, and the 0 in the middle, which we don't need, and then minus 9. And let me make sure I did that correctly. And I did. Makes me pleased. So, there you have it. That's how to multiply polynomials. Again, it doesn't get you away from reading the section, especially that page 4 I was talking about. I'm kind of proud of. But anyways, please do the reading. Go back and do the reading if you haven't done it already. And do your exercises. Don't let me do all the work for you. You need to practice these as well so they become second nature to you. And I like them to be that way for you so it's easy to multiply. Okay? Well, this is the end of section 4.3, and look forward to the next section, which will be multiplying binomials together, which has an interesting feature to it. We'll talk about that next time.